Hello everyone, today we'll be going through a popular stream processing scenario where we are performing spatial analysis on stream features and monitoring movement within buffer zones. This is known as geofencing, which can be combined with other processes such as filtering, enriching, and transforming the captured data. With FME, you can perform spatial analysis on stream data to vastly improve the efficiency of your workflows and quickly get the results you need. In this scenario, we are tracking a vehicle fleet that includes trucks hauling hazardous materials. According to the city bylaws, these trucks are not allowed within 100 meters of a school. We'd also like to track when they enter within 200 and 300 meters of schools for safety reasons. Our workspace reads from our fleet tracking stream source and creates 3 different distance buffers around all schools and checks if a truck's current location is within a certain buffer zone. Now let's get into the demo now. So here's our workspace, which starts off by reading from our Kafka message queue. And this is tracking our entire vehicle fleet, and it's a medium volume stream, and we're getting fairly frequent updates from our vehicles' locations. Currently, I have set the mode to run in batch mode just so we can inspect the feature caches, but when actually deploying the stream, I would set it to stream mode. We're using the JSON flattener to create or to extract those attributes that contain the vehicle ID as well as the point geometry attribute that comes from the original JSON payload. And then we are filtering down the results to just our 2 hazardous vehicles based on the vehicle ID. And then we are creating point geometries from those geo attributes. We also have our schools dataset that we want to create our geofences around. So we have 3 buffer transformers to create our 100, 200, and 300 meter buffer zones. And then we're just using an attribute creator to tag all of these with a new attribute to indicate the size of the buffer distance. And then we are reprojecting all of our results to then match with the coordinate system of our trucks. And then that brings us to the spatial filter. Here we've set the spatial predicates to test of whether the filter contains the candidate. In this case, the filter is the school buffer zones and the candidate is the truck feature. So we're just checking which of those buffer zones the truck currently falls within. Note that we have the filter type set to filters first because order matters in this workflow. Because our school zones are the filters. If those don't arrive first at the transformer, then our trucks will not have anything to join against, and they won't be able to have anything to compare with, and they will all be rejected. And lastly, once we have our past features that have been contained inside a buffer zone, those go through our test filter to check which of those buffers that they go through based on the buffer distance attribute that we created earlier. And then if you want to do any downstream processing such as email notifications, HTML reporting, or writing to a database, you can do that all here. So we had our Kafka connector set to batch mode before, but we're going to switch it to stream mode to run continuously and then run the entire workspace to show those features coming through our stream. Be sure to follow Safe Software for more quick demos and check out the FME community for more in-depth tutorials and webinars on stream processing.